LabTV travels to the Armed Forces Institute of Regenerative Medicine's Wake Forest facility. Working with the U.S. Army, scientists there are doing some amazing research, and they're using ordinary inkjet printers.
I work in the area of bioprinting, which is the process of taking a normal desktop inkjet printer and you load the cartridges with cells instead of ink. And just using the normal method, just printing out a sheet of paper, you can print out a human tissue instead of ink.
With this new technology, doctors will be able to print skin cells on soldiers and other people with burns.
The Army is interested because burns can account for 10 to 30% of all casualties on the battlefield. The technology that we're developing isn't just going to be for the Army. We're hoping that eventually we'll be able to extend it to firefighters or policemen or other people who put themselves in the line of fire.
When people get burns, it's serious. That's because burns damage our body's most important line of defense, our skin.
Skin is incredibly important. It's the largest organ in your body, and it does things like retains water, it retains heat or gives off heat, and it helps provide a very important barrier against infection. So losing a large amount of skin in a burn can cause severe problems.
Burn patients might heal a lot faster if their wounds could be covered with new skin cells. But it's not as easy as it sounds.
A wound from a burn, it's not going to be flat. It's going to have a bunch of jagged areas. And in those jagged areas where the wound is deeper, you need to put a different cell type. So the cell type in the skin that's on the top is not the same that's going to be on the bottom.
They'll need to fill in the wound with two types of skin cells, fibroblasts and keratinocytes.
Fibroblasts are what make up the deep layer of the skin, and those help to produce the matrix that helps to keep the skin held together. Keratinocytes are the cells that make up the top layer of the skin.
The scientists can take healthy cells from the patient and then grow them in an incubator. Once they have enough, they load them into inkjet cartridges that have been cleaned and sterilized.
So this is how the skin printer will actually work. This is a patient bed. The print head is going to be mounted in the middle on these tracks, which will allow it to move across the body.
A camera scans the patient's burn and uses a laser to create a 3D map of the wound. Then the computer tells the printer where to start printing and what kind of cells to use.
So this is a normal inkjet printer that we've taken apart, modified for cell printing. We just load the cells right where the ink goes instead of ink. Now here is a regular inkjet cartridge. Now when the printer wants to drop a drop of ink, it simply sends a signal to one of these resistors, which heats up this copper wire, and that causes a bubble to form in the ink, which drops out a drop. That drop is roughly the same size as this cell, and that's how we can get single cell precision.
So the bioprinter drops each type of cell precisely where it needs to go. The wound gets filled in, and then those cells will become new skin.
I've always been interested in science. In middle school and high school, I was able to look at chemistry, look at physics, look at biology, earth science, all these different things, so you can find out what interests you and pursue that path.
And then you can do some amazing things, like turning an everyday printer into a machine that saves lives. To find out more about skin, burns, and bioprinting, check out labtvonline.org.